Thanks very much for coming here, everyone. So I'm going to talk to you today about the SH2AMROCK Hydrogen Valley Project, which James briefly introduced there. So I'm going to talk first of all about why hydrogen. It's a gas, it's an element, it's a molecule that people have heard about. So why are we talking about that? I'm going to talk about what this thing about a hydrogen valley is, what that means, and then basically what that might mean for Ireland, and more specifically what that could mean for Galway. So first things first that I need to do when I talk about hydrogen is I need to rip the band-aid off. I need to get the ugly stuff over with first. Okay? So why would anyone be interested in working with hydrogen? It's got a reputation. So first, let's talk about its reputations here. Currently dirty. Okay, so one thing that I will mention when we're discussing hydrogen is when you use it, when you convert hydrogen to energy, and if you burn hydrogen, if you extract its chemical energy to make some useful work out of it, when you do that conversion of hydrogen to energy, it's actually very clean. The only byproduct is water. Okay. The problem is with hydrogen, it doesn't occur naturally in a very useful way to us. 99% of the molecules in the universe are hydrogen. They're unfortunately in stars, right? It's going to be very, very difficult to get access to those hydrogen molecules in stars. There is hydrogen on Earth, and it's present in the form of water and hydrocarbons, fossil fuels, buried under the Earth. So we can liberate that hydrogen by doing some work to it. Right now, hydrogen is a very, very widely used substance in chemicals production, in oil refining, in fertilizers, in plastics. Hydrogen is produced, millions and millions of tons are produced every day, but not generally for the purpose of energy, for the purpose of making chemicals and fertilizers and these things that want it. And because they want to do that cheaply, they extract it from the cheapest source of hydrogen that we have available to us, and that's fossil fuels. So when I say that hydrogen is currently dirty, and I talk about something called grey hydrogen, that means that to make hydrogen right now for chemicals production, for fertilizer production, for all these things, hydrogen is ripped off of a methane molecule, a natural gas molecule, ripped off, and that remaining piece of natural gas, carbon, goes up into the atmosphere as carbon dioxide. So making hydrogen the way it is usually used in industry is dirty, okay? And because there's inefficiencies in producing that hydrogen, if we compare, this is how engineers in energy think about how dirty something is. They think about the grams of carbon dioxide that gets released for the kilowatt hours of energy that you get from it. Because there's inefficiencies in making hydrogen, it's actually dirtier than natural gas. Okay, so we need to think about the life cycle of hydrogen. We can't just think about burning it, making energy. Happy days, water came out the tailpipe of my vehicle. We have to think about where the hydrogen comes from. So most of it comes from fossil fuels. So bear that in mind. It is currently ridiculously expensive, right? It is made millions of tons a year, a day, hundreds of millions of tons a year of hydrogen are made, but they're not made for energy purposes. They're made for chemicals and fertilizer purposes. So hydrogen is not generally being made to be cost competitive with fossil fuels. So it is generally at this moment quite expensive. So these are some sort of broad ranges, quite a big range for how many euros a kilogram of hydrogen costs. If you're producing it dirty, it'll be down the lower end. If you're producing it dirty, it'll be at the higher end. Because we don't go around and trading in units of kilos of hydrogen very much. I've converted this again to units of energy, to megawatt hours of energy. So the absolute numbers here aren't really that important, but the comparison numbers are. So how expensive is hydrogen compared to natural gas? So 60 up to 450 compared to 27. Diesel. There's some hydrogen devices that are comparable to diesel, but again, it is expensive. It is, and that is because it is currently not being manufactured to be an energy product. It's being manufactured to be a chemical into other things. It is always hazardous. It will always be a hazardous gas. We'll get the Hindenburg mentioned now, the big hydrogen-filled German airship that first into flames in the 1930s. It was filled with hydrogen as a lifting gas because it's lighter than air, and that hydrogen caught fire, and the airship burnt, and lots of people were killed. And it really is that moment that happened in the 1930s, nearly 100 years ago, has remained in the public consciousness about hydrogen. It is a hazardous, it's a high energy combustible fuel. If it were not combustible, we would not be interested in it as a source of energy. But I refer you back to hydrogen is produced, hundreds of millions of tons every year of hydrogen is produced. The vast majority of it is done safely. And that's because we have safety systems set up for hydrogen production. I'll come back to that. It is sometimes an inefficient use of energy. So converting, I'm going to be talking about using electricity to make hydrogen. I'm not in any way interested in this using natural gas to make hydrogen. We don't have much fossil fuels in Ireland. We've got one gas field in County Mayo that's on the way out. In a few more years, there'll be no more gas to extract from it. So we're here to talk about renewables. We're here to talk about an actual long-term sustainable form of energy. So I'm going to be talking about a way to make hydrogen from electricity. We think in terms of efficiency when we do engineering studies on hydrogen. So of the energy, of the electrical energy I put in to make hydrogen, how much of it actually presents itself as hydrogen? And in the best case, it's about 70%. So you lose 30% in the making of hydrogen. You then lose another chunk of energy if you want to turn on hydrogen back into electricity. And we're sort of getting at the idea of, is this kind of like a battery? Well, yeah, it kind of is. I'm going to be talking to you about using hydrogen kind of like a battery to store renewable electricity and use it at a time and a place where you don't have the renewables. But overall, we lose the vast majority of the energy that we begin with hydrogen. We're going to compare that with the lithium-ion battery. You get more or less, for every 100 units of electricity that goes into a lithium-ion battery, you get 80 back. Okay, and that's real life efficiency. They're extremely efficient. And it's hard to move. It's the least dense, it's the most plentiful substance in the universe. It's the least dense substance in the universe too. So moving large quantities of it is very difficult. You have to find ways to compress it, make it smaller, make it more concentrated. And then you can start to move it in cost-effective amounts. And because the molecule is so small, it leaks. It leaks not out of everything, but it leaks out of a lot of things that we currently use to move energy around. So why bother? Right? Why would we do something that has got as many flaws as this? Well, that's because the challenge we're facing with decarbonisation, with energy security, is a pretty serious challenge. And in order to do it fully, we're going to need every solution that's presented to us. So what are the challenges then? Well, we have the challenge of decarbonisation. And when people think about sustainability, a lot of us think primarily about environmental sustainability. There's many aspects of sustainability. It's great having an environmentally sustainable solution, but if it's not economically sustainable, if it's not socially sustainable, if it's not technologically sustainable, then it may not work. But we have got a decarbonisation challenge that we have signed up to, that the European Union has signed up to, and we are falling well short of that challenge. Maybe something that's a bit more salient at the moment is energy security. So these two graphs, this is showing, let's go over to this graph first. This is measuring something called import dependency. And it's a measure of how much of a country's energy is imported, how much is produced within the country itself. Here's the European average. So about half, a little bit more than half of the energy used in the European Union is imported from other countries. For Ireland, our number has historically been up around 90. We have recently had a bit of a drop, but we're on our way back up to 90 again. Now, why are we on our way back up to 90? What caused this drop? Anyone? Any suggestions? What? Sorry? COVID. No, this actually, you've highlighted my slides are out of date. I don't have COVID in here. This is pre-COVID. This is around 2016. This drop happened. Car gas field. So this is the fact that we found fossil natural gas, technically called natural gas. It is a fossil fuel found in the County Mayo. We were able to reduce imports of gas from other countries during that period. So a lot of people look at that and go, "Oh wow, wind did that." Unfortunately, not that drop. Wind has contributed to this, or maybe has stopped it rising. But this is through the fossil fuels. Now, as that gas field runs out, we're going to creep back up. We're going to probably, if I had more up-to-date slides, we would see that this is crept back up. This is another just look specifically at natural gas. How much natural gas we produce indigenously in Ireland. This is the last of the Kinsale gas down in Cork. Here's the gas up in Mayo coming on stream, and it's like a balloon filled with air. That gas field is gradually running itself down, and there'll be a gradual long tail, and eventually someone will say, no point in extracting gas from this harsh offshore environment anymore. We'll pull it lower. And in that case, we're going to go back to importing all of our natural gas needs. Why is natural gas important? It's the main fuel that we use in Ireland for generating electricity. And another thing then is we have got surging demand in Ireland for energy, for all forms of energy, but I guess electricity is the one where it's becoming most apparent. We have a growing population, fastest growing population in Europe. We also have increasing demand from the industrial sector. Most people are aware of this surge in data center energy consumption. That's happening. So these two factors, data centers, population, serving to increase our energy demand, and it is being proving very difficult for our energy system to keep up with that. So what's been the European level response to this? Well, this is kind of starting at the short term, middle term, long term here. Europe has come up with 3 strategies, all around this idea of what's called the green, the EU Green Deal. So the Fit for 55 package is 55 refers to the percentage decrease in emissions from, what's the base year for that? I think it's emissions from 1990 down to 2030. So 55% emissions cut across Europe. Different countries count that in slightly different ways. In Ireland, we call it a 55% cut. We call it a 51% cut, but from 2018. So this is in the short term. This is about greening Europe. Repower EU then was a set of policies that was put in place after the Russian invasion of Ukraine. And the idea here is very much focused on energy security, getting Europe off imported energy, particularly Russian. Getting Europe off imported Russian energy, keeping us on imported gas because it was viewed that we need to get off Russian gas immediately. The alternatives within Europe, the clean alternatives within Europe, maybe not there in the time frame that's needed. So there's going to be a diversification of gas supplies. So Europe is mostly off Russian gas. There's a few countries in Europe that are still importing Russian gas. They're generally countries that are landlocked, that are not able to build these liquefied natural gas terminals to quickly get different alternative supplies of gas in. Targets to use less energy, become more efficient, conserve more. Indicators. We suggest limited success in this so far. I kind of felt that even in the early days of the invasion, but Dr. Wood was not taken that seriously. You sometimes see if you're watching Champions League matches, they're very cringy ads about conserving energies funded by the European Commission. I think that seems to be the extent of public messaging on energy efficiency coming from Europe. And then plans to accelerate clean energy in terms of massively increased investment and accelerated planning processes. Ireland's not the only country in Europe that is having trouble getting infrastructure built. This is a Europe-wide issue. So Repower EU is all about diversifying gas suppliers, getting off Russian gas, hopefully using less energy and increasing the amount of clean energy we produce ourselves. And then finally, the long-term goal is to get Europe to be a net zero bloc by 2050. So that means reduce emissions down as much as we possibly can. And if there are any residual emissions, use technology that can pull the same amount of carbon dioxide or greenhouse gases out of the air as well. That is to net zero. So these European plans have sort of come together in how they matter for energy is a plan for energy system integration. Okay, and there's a prioritization that Europe has and that countries then start to implement in their national laws around top priority energy efficiency, doing the same or more with less. So can we, things like lights, improvement of lights, improvement of energy efficient boilers, anything that we can deliver the same end energy service for less input is an efficiency measure. Circularity is the next priority. This is all about, can we use waste products from something as an energy source for something else, right? And the real example in Ireland here that we have is anaerobic digestion. This is an idea of we've got from the agricultural sector, we've got lots of animal slurries, animal waste, and that is a source of energy. And anaerobic digestion is a technology that can convert that into something that is chemically really like natural gas, but it's renewable. Other things with circularity, district heating, capturing heat from waste energy, from heat that's going up the chimney of an industrial process. That can be put into pipes, it can be moved around, it can be delivered to people's homes. This is not rocket science, we just haven't done it yet, really, I'd say. The one that people are probably most familiar with is the third priority, or direct renewable electrification. So this is all about using more electricity to offset fuel use and making that electricity come from renewables. So why do we want to use more electricity? Well, electricity has shown itself to be, if not easy, the least difficult of the energy sectors to decarbonize. We know how to build wind farms, we know how to build solar farms. Other countries know how to build geothermal. There's lots of different ways we can make electricity zero or low carbon. So the more electricity we can use to offset direct use of fuels, the better we can, the more of an impact we can have. So this is why we support EVs, right? Why the government supports EVs. This is why the government supports movements towards use of heat pumps, getting a home to be heated electrically rather than by fuel means that it can be that the electricity source can be decarbonized. And then finally, for all these things that are just really, really, really difficult to do and cannot be done or can't be done fully by these other ones, it's recognized by most that there are some processes in our energy sector that will need a fuel. For the foreseeable future, for the long term, we will need some form of fuel. I'm going to talk about some of those in a minute. So one of those fuels is hydrogen. And the term it's used is hard to abate. And hard to abate basically means sectors that are really difficult to decarbonize by any other way. So this is where the EU and people like me who work in this area foresee a role for hydrogen and fuels in the decarbonized system. It's to get these last, most tricky bits of decarbonization done. So for Ireland, every country is different. Ireland's different from other countries in Europe. First of all, we're an island. We've got 2 jurisdictions on the island. We don't have a huge amount of heavy industry, but we are very, we've got some other dependencies. So this is, so some of these sectors are common with other countries. Aviation is seen in many cases as a really hard to decarbonize sector. Long distance shipping, industrial processes, heavy duty transport. But then there's some things that are unique in Ireland. Data centers. Ireland is, at the moment, somewhere between 1/5 and 1/4 of electricity in Ireland goes towards running data centers. The European average is about 4%. So this is something that's how do we decarbonize these sectors? These centers. They're not just electricity users. They're showing themselves to be pretty inflexible electricity users. They are using electricity all times of day, and at the moment they're only being built in the area around Dublin. And that grid around the electricity grid around Dublin is getting saturated now with demand. And the other sector is this. This is not showing a picture of wind turbines. This isn't something that generally features in many people's assessment of a hard to decarbonize or a hard to abate sector. But this is something in Ireland. I'll talk about that in the next slide. So a small windy island like Ireland, we're using, when we're approaching that energy, that direct renewable electrification in Ireland, we're doing it primarily through wind. We're starting to see a big rollout of solar at the minute, but wind is doing most of the heavy lifting. The minute it's all onshore, hopefully in the near future, it'll become offshore as well. But this is what we're trying to decarbonize. So this is a month of electricity consumption data from, this is maybe a couple of years ago. It's a month. You can see a really predictable daily pattern here. You can see Monday, Tuesday, Wednesday, Thursday, Friday, weekend. Maybe this is bank holiday. It's kind of low, but the weekdays and the weekend, right? And so each of these is a day. Each of these represents people waking up, making their breakfast, longer in the middle of the day, and then making their dinner and going to bed, right? So you can see the activity of a society through the electricity consumption, and it's really rigid. Okay, that's one thing. Now this is Ireland wind generation for that same period, and this obviously is high when there's wind and is low when there's none. So if we are pursuing a pathway of decarbonizing our electricity system through renewables, we are going to want to increase this. Okay, it is in our interest. We've shown we are good at generating wind electricity in Ireland, but there are some times that we are going to have too much, and there's sometimes where we're not going to have enough. And at the moment, when we don't have enough wind electricity, the major thing that we do is we fire up fossil fuel power stations, right? So these gaps are made up. This gap in electricity is made up from running gas, oil. We've had coal, we've had peat, we no longer have those, thankfully, for generating electricity. But this is mostly gas and oil power stations making up the gap. There is some hydro in Ireland, but just for the sake of argument, I'm just talking about wind and fossils here. So if we build up more and more wind, what are we going to do to fill this gap? There'll be some times in the year or a month where we'll have more electricity than we need, and some where we still don't have enough. So energy storage is going to be important. Interconnection is going to be important. Building huge electricity cables to our neighbouring islands, to continental Europe. This is all underway. But there's going to be some role for storage. Now, what are the storage technologies that are out there? Well, this is the energy stored in something called a PHS plant, a pumped hydroelectric storage plant. This is in County Wicklow. This plant recently celebrated its 50th birthday, and this square represents the energy stored in that plant. Okay, so this is, how does this plant work? Well, at night time when we have excess electricity, this plant runs big pumps, and it pumps water from a low reservoir up to a reservoir that's been carved out of a mountain in Wicklow. And then when that energy is needed, when supply is low or when electricity is expensive, the gates are opened in the top reservoir, flows down, runs through turbines and generates electricity, runs through big water turbines that generates electricity. And this blue square represents the scale of the energy stored in that plant. This gap between the red and the black represents how much of the gap between renewables and demand there is. We would need to carve out an awful lot of reservoirs in an awful lot of mountains in Ireland to fill that gap with pumped hydro storage. Well, then people talk about batteries. Batteries have been shown to be an excellent way of storing energy and delivering that energy quickly. This is the largest battery plant in Ireland. It was, until 2 years ago, the largest battery plant in Europe. This is, again, proportionally, this is the size of the energy that's stored in that battery plant. So you might be saying, oh my God, we need hundreds or thousands of these battery plants. This is in County Offaly. It's, I forget the name of it, but it's yeah, I think it's called Lumclue battery plant. It's a 200 megawatt hour battery storage facility. So it's a, as battery plants go, it's very, very large. still one of the largest in Europe. What battery plants are great for is delivering energy quickly, not for storing it for very, very long periods of time. So what battery plants in Ireland are doing now is looking at these times when the wind falls off real fast, and they will give you a few more minutes, a few more hours of energy. They're not designed to fill this whole gap. So I'm going to talk then about an alternative to these ways of storing energy. Oh, sorry, I should have brought this up earlier. This is if we double the amount of wind energy. I've just doubled, say, the scale of wind energy. So just imagine if we produce twice as much. And you see that we sometimes have extra electricity, but there's still times where we don't have any. So we've still got that big gap to fill. So I'm going to talk about hydrogen, and in particular something that is colloquially called green hydrogen, as a potential way to meet this, to fill this gap. So what is green hydrogen? Well, first of all, hydrogen has no color. It's a colorless gas. Green refers to how the hydrogen is made. I said grey hydrogen back in my early slides, and that was a reference to producing hydrogen from fossil fuels. Green hydrogen is obviously producing hydrogen from renewables. So what do we do? Well, first of all, we need a source of renewable electricity. That renewable electricity is generally meeting electrical demands. But if we have extra electricity, if we build up wind farms that are in excess of what we need, or that we intentionally overbuild them because we want to have extra energy at certain times of year, we can divert that extra energy through a process called electrolysis. And that electrolysis uses electricity to split water, H2O, into hydrogen, H2, and oxygen, O2. And that hydrogen can be stored. Talk about storage in a moment. It can be stored, it can be moved, and it can be used at a different time at a different place when you don't have that renewable electricity available to you. So it's almost like a battery. But it's a battery that is capable of storing energy for very, very long periods of time at huge volume. It does have problems with its cost. It does have problems with its efficiency. But delivering this energy storage by other means is proving to be very, very difficult at the moment. So once this hydrogen is produced, it can either be compressed to a high pressure so that we densify it and we make it easier to move. We can chill it down to really, really low temperatures and make it a liquid, and we can move it around. Or you can make other sort of carrier chemicals to move that hydrogen around. And the key thing that gives you is storage. So we could think about pumping hydrogen into old gas fields. We could look at our gas field up in County Mayo, the Copper Field. It held fossil fuel gas in it for probably something like 50 million years. We've used it all up now. Over the course of 25 years, we'll be all gone. But that rock structure, which so long as we didn't damage it by extracting the natural gas, that rock structure is still capable of holding high pressure gases. So we could conceivably use an old gas field to store hydrogen at pressure. There's projects underway at the moment that are looking at the old Kinsale gas fields and storing hydrogen there at pressure and extracting it for times when we need it. And then once we have that hydrogen, we buffer it, we use storage to kind of buffer between differences in time between supply and demand. And then we can use it in those hard to abate sectors that I talked about, in heavy transportation, in air and sea, in long-term energy storage, and in the chemicals industry. So what then is it? So that's the kind of the theory of hydrogen, of where it could be used in the energy sector. These sectors are hard to abate, and because we don't have fossil fuels in Ireland, they are import dependent, highly, highly import dependent. So what are we doing then in Europe around encouraging the deployment of hydrogen? I talk here at the bottom about scaling is a challenge due to chicken and egg, right? So show of hands, what came first, chicken or the egg? Who says chicken? Who says egg? Okay, well, I don't know. I know there's some logic to it somewhere, that at some point something laid an egg, but it wasn't a chicken and a chicken popped out. So I guess I'll make the egg first. But anyway, but the point I'm trying to get at here is if no one in Ireland is producing hydrogen at scale, and if no one in Ireland is using hydrogen at scale, well, if everyone realizes or recognizes, or hopefully being a persuasive person, hopefully we can see that there might be a role for it in Ireland. Who goes first? The plant that builds it or the people who use it, right? I can't just rock up the bus Aran and say, buy 10 hydrogen buses. And then say, okay, show me the hydrogen. Well, I can't make the hydrogen yet because I've got a buyer for it. I can't go to Monaghan or ESB and say, build a hydrogen plant at your wind farms. And then say, well, who's going to buy it? I will work that out later. So that's the kind of, when people talk about chicken and egg and hydrogen, that's what they mean. They mean that because we don't use it for energy yet, there's nowhere in the supply chain doesn't exist. So that's the idea of a hydrogen valley. It's relatively easy to do demos of nearly any energy technology, to do small scale one-off trial of a technology. And people can say, yep, we did it. We tried fueling our buses, we tried charging our buses, we tried doing things at small scale. And where we want to be is over here on some industry or economy-wide implementation of a new technology. But there's this, what maybe people in this room, people working in this building might call the valley of death. There's that stage between the idea being tested at a very small scale and being taken on, that there's currently no funding available or no support available for. And hydrogen falls into this because of this chicken and egg issue around you can't make the supplier build the plant because there's no off-taker. You can't make the off-taker buy the vehicles because there's no supply. So what we have tried to do in Europe is find that market with funding and support for hydrogen valleys. So what is a hydrogen valley then? So it fills this gap, this valley between the tiny demos, the one-off vehicles for a few months, and this kind of vision of where hydrogen might fit, decarbonising all these hard to decarbonise sectors. And we fill this with a valley. So some things about a valley. It needs to be large scale, so at least 10 million euros of funding. It needs to have the full hydrogen value chain, so everything from production to transport to storage to end use. It needs a clear regional scope, so it needs to be, can't be producing hydrogen in one place and using fossil fuel produced hydrogen somewhere else. We need to show that there's the entire supply chain in one place. So that is, so Europe has implemented a process of funding through this organization, the Clean Hydrogen Partnership down there, a program of funding these hydrogen valleys to get over the chicken and egg problem. So the first one was funded up in Scotland, in Orkney, as hard to decarbonise places as ever. There is surrounded by amazing renewables, but totally isolated. So hydrogen was used in decarbonising operations of port there. So these have spread since then. There's about 20 or so, 22, I think, at the moment funded across Europe. Galway is one, okay? It's not just Galway. But Galway is where most of the action in this is happening. And I'm going to spend the next little while talking to you about what this SH2AMROCK Hydrogen Valley Project is. So first of all, the team. SH2AMROCK is a project that was led by the University of Galway. We're what's called the coordinating partner. We need to ensure that this project happens. And then we have a number of infrastructure partners. These are companies that are delivering infrastructure, either rolling on the roads or built into the ground in Ireland. And most of the infrastructure is going to be built in County Offaly or County Galway, or County Offaly or Galway City. So some of the names here are household names in Ireland: Bordnamona, CIE, Galway Port, Aran Islands. Some of them are companies you won't have heard of. People of a certain vintage in Galway might have heard of or might know a company called Cold John. They used to operate big bitumen storage tanks. They would import essentially tarmac from outside Ireland, process it into road making material, and store it there. They're now called Colas. They do the exact same thing. So we're working with some big energy producers, big energy users in Ireland, as well as with some specialist companies in the hydrogen sector. And we're going to be building an infrastructure that I'm going to show you in the next couple of slides. And then what makes this a valley as opposed to just a hydrogen project are these organizations at the bottom. These are primarily universities. There are also hydrogen trade bodies. I think Cormac Walsh in the room here from Energy Cooperatives Ireland. This is an organisation that is trying to help people in communities take control of their own energy. So these companies and organisations are involved in helping us learn about what's happened in other hydrogen valleys, learn from their mistakes, learn from their successes, but also help others learn from what we do, learn from the mistakes we make and the successes we have. And these are the countries involved. This obviously is not my most up-to-date slide because I did put Belgium on there because my Belgian partners in the project were really annoyed they weren't shown. So unfortunately, they fall off again. But just some facts and figures. We were awarded funding back in 2022. We had a bit of delays in getting the project off the ground, but formally started in 2024. 5-year program to build and operate the project, or 5-year program, 3 years to build, 2 years to operate this project. Total project budget of north of 50 million euros for the infrastructure that I'm going to talk to you about in a moment. That might seem like an enormous number. It feels like an enormous number to me. In energy circles, that is not a big number, but it's a number that's going to get us started. We have received 8 million euro from the Clean Hydrogen Partnership to get over this chicken and egg problem in Ireland. Well, 7.5 million from the Clean Hydrogen Partnership and $500,000 from the UK government as well. And most of that funding is staying in Ireland with the infrastructure partners to support the purchase of infrastructure. So what are we aiming to do? We're going to be producing hydrogen on a wind farm in County Offaly. It's called Mount Lucas. This is an 84 megawatt wind farm. It'll be one of the bigger ones in the country, not the biggest, not in the top tier, but quite big. Operated by Monaghan in old peatland, old peat production land. And this is a representation of what the hydrogen. So this wind farm exists. This hydrogen plant does not yet exist. It is a representation of what it will look like. Hydrogen will be produced. Oh, the good thing is we have planning permission for that. Planning permission has been granted for that space, but that's really important to mention. So we'll be producing hydrogen from wind energy coming from this wind farm. In general, we're going to be using wind energy that's produced by the wind farm at periods when it's not needed. So obviously at night time when people are using less electricity during those troughs that I showed you in that graph, these turbines are still turning. They don't know that it's night time. They just know the wind's hitting them. So we are aiming to use as much as possible excess energy from those wind farms from off-peak periods. There'll be some times where we have to just, if there's no excess, we're going to be using the wind coming from the electricity there. We are open to criticism there that says that the project manager of the SH2AMROCK project has just walked into the room now, so she's my boss on this, or she bosses me around. Grace, this is Grace Manning. So we're aiming as much as possible to use excess electricity. I'll come back to this topic in a minute. It's maybe a slightly nuanced one. But hydrogen will be loaded into trucks at high pressure and driven to Galway. And on the Galway side, we're going to this is the view of what's called the Enterprise Park at Galway Port. So it's an unfortunately cropped picture. There's the Harbour Hotel. The inner port of Galway is there. The train station is here. There's the train line. Dublin's that way. So we've been granted some lands at the port to develop a hydrogen fueling station here. And that fueling station, just look at who the tenants around us are. CIE, the operators of the CityLink, Colas, and the City Direct buses. So we've got lots of big vehicle fleet operators that are operating in this hard-to-abate sector. And we have this industrial process that produces bitumen for use in the roads. So we're aiming in this project to from the deployment of 3 double-deck buses for operation in the city. But more exciting is 10 intercity coaches. So Galway is the biggest of operations for bus Aran coaches that go from Derry down to Cork. And these are buses that have got really, really long range. In all of the studies that bus Aran have done, they have not found any practical way to decarbonize these in any way other than buying something called HVO. HVO, people might have heard of this. It's a biofuel. It's chemically extremely similar to diesel, so you can burn it in existing engines. But there are real concerns over its provenance. Is it being made in a sustainable way? Is it actually a biofuel, or is it just diesel with a sticker put on it? Because most of it is produced outside the European Union, and it's not quite clear that standards are being adhered to in the production. Logistics trucks that will be used by Colas and some other companies, and a small number of vans and minibuses. We're going to use the hydrogen to decarbonise the operation of this bitumen plant in Colas, former Colchon site. So there's some big storage cylinders here. So there's some oil cylinders here for storing oil at the port, but these other ones store bitumen, and that bitumen has to be kept hot at around 200 degrees. If it doesn't get kept hot, it solidifies, just like it would on a road. We don't drive on liquid roads. Well, we drive on water, but we don't drive the roads becoming liquid, so we have to keep this stuff hot before it goes onto the roads. And they currently do that by burning copious amounts of diesel to keep that stuff hot. So we're going to be replacing the fuel supply to one of these tanks with hydrogen. So we're going to keep that tank hot on renewable energy rather than on fossil energy. We're also working with Aran. We'll be doing a hydrogen aircraft demonstration. Buying a hydrogen aircraft will be too expensive, way beyond the budget of our project, but renting one should be something we should be able to do. So we're working with Aran Islands to get their flights tested from the mainland to the Aran Islands. And then there's a number of studies. I won't go into the utility study. These are being done both by us in the university and by our partners in the project on scaling up the piloting, sharing information from Ireland and Galway to beyond. So where am I at the minute? Well, we've had some successes. We have got planning permission granted, planning consent for the hydrogen production side. We're not yet there on the fueling station side. We've got a bit more work to do on that. We're learning, and this might seem like a sort of a minor thing, but we're learning about hydrogen as a team on this project. So I come from a background, I've done a master's on hydrogen technology, I've done a PhD in hydrogen technology. I know nothing about operating bus fleets. I know nothing about storing bitumen, and I know nothing about flying small airplanes to the Aran Islands. And so I'm not involved in those things. But I need to learn about what the partners in this project businesses are, because we need to come up with a way of using hydrogen that works for everyone. And the partners then, they need to learn about hydrogen and how that fits into their business. So we've had a lot of success. I feel we're all on the same page now. We have enough knowledge about each other, we have enough trust in each other, and we have enough ability to speak as one voice. And we're using that one voice to try and communicate with policymakers. Because one of the big barriers that we have at the moment is funding support. I talked about 50 million plus for this to make this project a reality, and we have 8 million from Europe, which is brilliant, but that's still a big gap, and we need further assistance in closing that gap. When Europe grants money for funding for projects like this, they expect that the national policy will kick in, and that there'll be national funding support for that. We contributed to the writing to the review of Ireland's national hydrogen strategy, which was released 2 years ago. And this project is actually referenced in that strategy as being an absolute exemplar of how hydrogen should be done in Ireland. We're using renewables, we're decarbonising, only the very hardest things to decarbonise. But we are still finding it very, very difficult to draw funding down for this project. And that's just because things just happen really slow sometimes in policy making. And the worry is that the EU is going to say, okay, where's our project, guys? So we need to push things along. We can't just be waiting on this national funding. So we are looking at other sources of funding too. We want the Irish government to fund us, and we want to work with them as much as we can. But it's a bit of a challenge sometimes. So timelines, those are the main things. Wrong side of the road. We're one of a very tiny number of EU countries that drive on our side of the road. So buying European vehicles, which we're encouraged to do by this European project, is really difficult for us. So we are trying to get some allowances on the types of vehicle we're able to use in this project. So the next steps. Yeah, this is our next steps. But what we aim to do in this project is crack the chicken and egg problem. And then once we're the first in place, that's going to unlock a lot of projects in Ireland that are trying to get going. They might have hydrogen demand, but maybe not supply. They might have hydrogen supply, but maybe not demand. This is relatively new technology for Ireland. We would expect there to be hiccups in our project. There'll be times when our hydrogen production may be offline. We would love there to be other hydrogen projects so that our users can get alternative supplies. So we want this to be the first of many. We want to serve as a template. I'll not get into the details of this, but Ireland is legally bound to build a network of hydrogen fueling stations around the island. And we want ours to be the first, and we want to encourage others to help build those. And yeah, that's good. We want to make this happen because we think until it happens, others are just going to watch and wait. So that's it from me. Thanks for your attention. And if there's time for questions, I'll be very happy to take them. So thanks.
Install microphone. So let's I'm going to speak loudly so people online can hear us with 15 folks on it. So Bill, yes. Who else had their hands up? It was 2 or 3. So Phil, I get the mic for you just to be sure. Anthony, can you be heard online?
It doesn't matter. Everyone can hear Americans.
Can you introduce yourself, Phil, and the institution ask your question?
Yeah, I'm Phil James from the Galway Energy Cooperative. Just 2 quick questions, Rory. One is, when you look at the map and you see the hydrogen production in Offaly, it doesn't appear to make sense to drive it to the west coast, around the bottom. And
yeah.
So I know the origins were partly in Galway, but how do you make the case for driving it to? I'll ask the second question.
Yeah.
The other was, when I looked at this a few years ago, Germany was a big leader in hydrogen development, and there was talk of a hydrogen backbone running all the way down Europe. So I don't know what that is.
So no, you're absolutely right. Producing hydrogen in Offaly for use in Galway. It was not the first idea we came up with. We did, our project was originally configured in a slightly different way. The hydrogen was being produced locally. And we drew down we were awarded the European funding for much more local production of hydrogen, but I guess the partner that was in the project at the time that was going to produce the hydrogen locally, they had to leave the project, unfortunately. So I kind of made a little allusion to a delay in the project. That was basically replacing that partner. They were doing a lot of really important things in the project. So we brought Bord na Móna into the project at that stage to produce the hydrogen. We brought VOC gases in to build our fueling station. And at that point then, I sat down last when the music stopped playing, so I became the project coordinator. But we did have a very big energy company based in Galway that was leading everyone to decide in Galway, but just commercial realities meant they had to leave that project. But we're delighted with the partners that we have in their place. The German situation, so I think there was around the start of COVID, lots of people got interested in hydrogen. Lots of people started funding projects, started announcing projects. There was a race for hype. I remember I was going to projects just around the time we got funded for this. I was going to conferences, in Europe, and I would present on this project and say we're aiming to build a 2 megawatt up to a 4 megawatt electrolyser. And people would literally laugh in the room and they'd say, that's so tiny. We're going to build a 2,000 megawatt electrolyser off the coast of Germany. And we're going to, put it in huge ships and sail it halfway around the world. A lot of those there was kind of an irrational exuberance around hydrogen at that time. People thought that it was further along the development pathway than it actually was. So a lot of those projects that were sort of touted for a long time were never actually real, were never going to happen. But at the same time, the amount of money being invested in hydrogen projects in Europe is almost doubling every year. Now that hype cycle would have seen it go up by a factor of 5 every year, but there is huge growth in hydrogen investment in Europe. It feels, the mood music is that hydrogen is in the doldrums, but that's because the hype didn't come to pass. but the real projects that were always going to happen are still there. Germany is still leading a project called the hydrogen backbone. It's still the European hydrogen backbone. That's a project to convert the fossil fuel natural gas key parts of that into pipes being capable of carrying hydrogen. And the idea there is to decarbonize Europe's industrial core with hydrogen supplied from the windy into the sunny places. So that's still ongoing. It's just it's a long-term project.
Next question.
Ian?
Thanks, James. So I'm just going back to that graph you showed about the difference between wind generation and demand.
Yes.
And you talked about the need for long-term energy storage.
Yeah.
And that's, I think, Airgrid's consulting about right now, so they're clearly keen on it. Do you see hydrogen providing that, or is it more about looking at the hard to decarbonize sectors like long-distance transport?
Maybe something I didn't make very clear in the presentation. To me, the most exciting, most interesting long-term application of hydrogen is for that long-term energy storage. And now I do think we're still going to need hydrogen in these hard to abate sectors, but I think the quantity that will be needed for the long-term electricity storage will be much bigger. I guess there's currently not a business case for long-term energy storage in any European energy market at the minute. So we're trying to get, again, this chicken and egg thing's a real killer. We're trying to get the hydrogen production up and running through the hard to abate sectors.
Yeah, and I think that's what the Airgrid consultation is about, is about providing a subsidy for
Yes,
storage.
yes, exactly.
It's a case for it.
It's currently not available right now. Yeah.
You mentioned Mount Lucas wind farm, and I think that wind farm is one of the few that's actually open to the public, has a lot of public amenities. Will your project affect that or in any way enhance that?
As far as I know, it won't affect it. I'm just going to show that picture here. So while this hydrogen production site doesn't exist, this area exists. This is the old construction yard from which the wind farm is built. It's currently off limits to the public. So short answer, no, it won't affect the existence of the wind farm at all. And people ask about water as well, because we need to split water to get the hydrogen out. The water comes from an on-site natural well. So this is a natural source of water. Oh, water natural, but it's a source of water on site. It's not currently being used as any drinking water. Yes.
Do you use the byproduct, like, so when you're splitting water, oxygen,
Oxygen goes the other, yeah.
is there any use for the oxygen?
There is a big demand for oxygen. And when we're scoping out this project in the kind of the early stages of COVID, obviously people were really interested in oxygen. Getting oxygen to hospitals was a big deal. This we could capture and sell the oxygen on. It would be quite expensive oxygen. You know, if we were to look to selling the oxygen sort of off to cover some of our costs, to make an impact, just given that hydrogen technology is still relatively new in Ireland and producing it from renewables is relatively new, it would be expensive oxygen. But there's been a project going on in Northern Ireland, not exactly where in Northern Ireland, but they have built hydrogen production at a wastewater treatment plant. And the problem with lots of wastewater treatment plants is, with growing populations, getting enough air into the wastewater to kind of gobble up all of the nasty stuff right in there. And so a way to enhance the operation of wastewater treatment plants is to use oxygen instead of air. So they demonstrated at a very small scale the use of a hydrogen production plant, taking the byproduct oxygen, and they did see a big increase in the throughput of that wastewater treatment plant. You would generally have to have one nearby in order for it to be cost effective, because moving the oxygen would be a little bit expensive. But it can absolutely theoretically be done. We're not doing it in this, just given the kind of the budget constraints.
Does it improve the air quality? So if you're releasing,
Question. I guess. Yeah. It would be such a vanishingly small amount. Yeah.
how do you market it?
Yeah.
Anybody who's online, you're also very welcome to stick up your hand. You can either put a question in the chat, or if you want to stick up your hand, we can unmute you and you can ask Rory a question.
Rory, curious. You mentioned earlier on in the presentation about storage and storage is difficult for, is that the biggest technological bottleneck, and it is, how is it being addressed right now? Where is it at? Where's the state of the art?
I would say hydrogen storage probably is the biggest bottleneck right now. There's ways of storing hydrogen much cheaper on really big scale, right? If we think about the cost of storing a unit of hydrogen. So if we were able to use the carbon gas field for storing hydrogen, storage cost of a kilo of hydrogen in that field would be really, really small. But the problem is, we would probably spend, a friend of mine in DCU did the calculations on this, you would spend 2 to 3 years filling the carbon gas field with hydrogen, generating no income, just producing hydrogen and filling the field to pressurize it enough to make something called cushion gas, so that you have enough of a pressure driver to get the hydrogen out when you need it. So that's, I would describe that as fairly low tech. There's a fairly low tech way of storing hydrogen like that. There are alternative ways then of storing hydrogen at smaller scale, which are really exciting. There's the idea that you could turn it into a different chemical, a hydrogen containing chemical. One of them is ammonia. So ammonia is the building block of fertilizer. It's 3 hydrogens and 1 nitrogen. So if you've got a source of nitrogen from the air, then you can make ammonia. And because it's a liquid, it's really, really dense. And it stores hydrogen much denser than even compressing hydrogen or liquefying hydrogen itself. It sounds kind of counterintuitive. But doing that at small scale is tricky. So there's lots of research at the minute to scale down the production of ammonia right now. And another thing that I've talked about is a technology called metal hydrides. These are metals, or porous metals. You tank them from the outside, they look like cylinders of gas. On the inside, it's all porous metal. You fill it with hydrogen, and the hydrogen bonds onto the metal with a much greater density, as if you were just storing hydrogen as a gas. Because it becomes part of the metal, it's really, really super dense. So that's another really interesting technology. So those would be the 2 storage ones that I'm most interested in. Yeah.
Mark, I can see you online. Let's give this a go if you want to unmute and ask a question. I don't think we're going to have a video feed.
That's fine. Hi, Rory, how you doing? Mark White here. You talked about the efficiency of converting hydrogen from electricity from hydrocarbons, and you're now talking about the density of hydrogen you can transport. But I'm interested to know a little bit about the energy density of hydrogen from the point of view of putting, say, trucks on the road. At the tank that they're carrying now for diesel, if that was filled with hydrogen, how far will the truck get by comparison with diesel, and therefore an idea of what is the energy density of the fuel when you transfer to it?
Yeah, thanks. That's an excellent question. So for the fuel itself, let's just remove the storage vessel for a moment. For the fuel itself, hydrogen has got 3 times the energy content per unit mass than a fossil fuel does, than diesel. So hydrogen has got 120 megajoules per kilo. Diesel has got around 40 megajoules per kilo. Now, obviously, because hydrogen is so diffuse, you need to store a huge volume of that in order to get that to get that 3 times energy benefit. So you store it at high pressure, that tank weighs a lot. And it weighs an awful lot, such that if you've got a tank of diesel, 90% of the weight of that tank is diesel. If you've got a tank of hydrogen, 90% of the weight of the tank is tank. So right. So the hydrogen tank is much heavier than the diesel tank to do the same amount. Now that's similar to batteries. Batteries are significantly heavier to do the same range. But hydrogen, so I'm more interested in comparing the energy density of hydrogen and batteries, because they're the alternatives. Hydrogen will get you about 3 times further per unit mass than batteries as well. For most day-to-day journeys in cars, we're not approaching that limit, right? So day to day, this is why you see no hydrogen cars on the road. And I actually saw a user, people who bought hydrogen vehicles in California are suing Toyota because the promises that Toyota made about fueling infrastructure didn't come true. So the huge class action lawsuit against Toyota. But so cars don't hit and vans don't hit and small buses don't hit that limit that batteries have, but the bigger trucks do. So buses get about, so at the big scale, hydrogen gets about 3 to 4 times more range compared to batteries, but it is definitely less than diesel in just the same way that electric is. I hope that makes sense, Mark.
Nothing.
Thank you.
Okay.
Are you holding up okay?
I'm good. Okay. Yeah.
We'll go for another 5.
Sure. This is the sort of.
Oh, you can double electric.
Yeah.
Sarah, online, I see your hand raised.
Hello, Rory and everybody else. I'm Darren Malloy from Inishmore. It's great that Aran is involved in the project. That's very exciting for us. It's a pity that none of the ferry companies are involved in it. Like, we have ferries from Doolin, we have ferries from Galway City, and we have ferries from Rossaveel, and together they use far more fossil fuel than the population of the 3 islands put together. So they are the big problem for us in decarbonising the 3 islands. It's the ferries, even more than the plane. Were they invited, and are they interested?
We are having conversations with them at the moment about getting them into the project. Yeah, absolutely. Yeah.
Thank you.
I really can't overstate how difficult the switch in lead partner was in this project. It really put us on the back foot for a long time. And I guess there's, as I said, if we were going at the project from the outset in an ideal world, in the perfect world, it would maybe be designed slightly differently. But I guess the project as it is now is a product of its own history.
Yeah, I was just wondering, can you make ammonia at the Offaly plant?
You could, but I guess it goes back to what I was saying to Paul here, that producing ammonia at small scale, at the minute, it's only doable at research level. It's not a commercially available technology, and we are pretty much maxed out at the minute on the funding that we're trying to get funding in for a project that's close to commercial. So it's, from a research point of view, it would be really interesting to study, but we just don't have the funds in the project to do that.
Yeah, because the reason I ask is I've seen it in the shipping industry that they're looking at ammonia.
Yes. It's being investigated as both a way of moving hydrogen between continents, but also as a way of powering those ships. Yeah, definitely.
Hi, Rory, Stephen here, PorterShed. I fear the answer is probably going to relate to the chicken and the egg again. ZEVI Ireland and UK, same acronym, different meanings, but zero emission vehicles here addresses both charging infrastructure and vehicles for battery, whereas the UK parallel kind of support is both for electric vehicles and hydrogen powered infrastructure. Has the government given any kind of insight on policy as to why they haven't leaned into that?
So are you talking about the funding that's available for zero emission vehicles?
Correct.
Yeah.
And infrastructure.
Yeah. So infrastructure. Okay, that's actually news to me. I didn't know that the UK funded infrastructure through that same program. So in Ireland there is funding for hydrogen vehicles through the ZEVI fund that we have in Ireland. You can get hydrogen vehicles funded, but there's no fuel. Right, there's no fuel for those vehicles, so you'd be sort of mad to just go out and buy a hydrogen vehicle. I wasn't aware that the same UK program that funds vehicles also funds infrastructure. So I don't know why the Irish side doesn't do that.
Yeah, there seems to be some kind of disconnect between the domestic passenger vehicle and the larger kind of HGV in the things. Something like that.
Yeah. So no, you can get the vehicle supported here at the same rate as the electric vehicle, but nothing on infrastructure as yet.
Oh, yeah. Take last three questions. So you're okay? So Grattan, you're next, and then you've got the final question.
Right, I just wanted to clarify the energy per unit weight point that you were making, because you said fuel tank is 10% of the weight and the hydrogen tank is 90% of the weight. So when you say hydrogen is 3 times per unit mass, that's just the gas versus the fuel.
That's just the gas versus fuel.
So can we do a comparison instead between the installed tank with fuel, the installed hydrogen tank with gas, and the battery? Is there someone does those metrics?
So the hydrogen plus tank versus the battery for the same weight, the hydrogen goes 3 to 4 times further. Yeah, for the same
Per unit weight.
for the whole system per unit weight.
As against the diesel tank?
As against the diesel, they're both inferior to the diesel, but the battery more inferior. But I don't know the exact breakdown of numbers. The whole point of hydrogen in these is that you will get close to the range of diesel, but not quite. Both, in recognition of this, European rules allow hydrogen vehicles and electric vehicles to be 2 tons heavier than their diesel counterparts to try and make up some of that lack of range. But the hydrogen, yeah, I don't have those numbers. The hydrogen, I've got the head-to-head for hydrogen and electric, but not for hydrogen versus diesel.
Thanks.
Last question.
How you doing, David Duffy Greco? Just a question there, have you an indicative program for your plan there?
A program, like as in a timeline.
What are you thinking, yeah, at the minute?
Well, so we need to have the clock's ticking on this. We are due. If you go, like, we're all over the European hydrogen website here. We're supposed to be finished by the end of 2028, right? And that's now are we on schedule? We're not exactly on schedule. We're not exactly on schedule, but
He's recording, Rory, now.
Yeah, exactly. So it's
Rather show me the money and then we'll be on schedule.
Yeah, exactly. There's a few questions around funding that we need to get answered before we can.
But it's never been done before either, in fairness.
Sorry?
It's an ambitious project, it's never been constructed before.
It hasn't been done in Ireland then. It's been done in a couple of places. We're learning a lot from a project that's going on in New York at the minute that a few of us are involved in.
But on the production side, that is, the planning permission is there, the
Production side planning permission.
technology is there, like that will happen, and it's to match it with the downstream.
Piggyback, yeah.
Yeah. Chicken and egg again.
Okay. Thanks.
Thanks for